Hello and welcome. My name is Mr. Gaffey and this is Gaffey's Grinds. This is video number 3 in our series on atoms, elements and the periodic table. Before we begin, the usual reminders that you should eliminate distractions now by closing any open tabs and by turning your mobile phone off or putting it on to do not disturb mode. A quick reminder that this channel is different from others because you get loads of opportunity to practice and really make sure that you understand and learn the information. It's different from other channels like that. If you want a much quicker video where you probably aren't going to learn as much, you just listen to someone say the information, then you should probably go watch a quicker video. But if you want to actually learn it and be able to use it, then you should stay here and you should do all the practice questions. Okay, in our previous video, we saw this. This is the periodic table of elements. So on 3, you guys should know what an element is from the previous video. So on 3, what I want you to do is I'm going to count to 3 and I want you to speak your answer out to the screen. What is an element? So 1, 2, 3. Okay, speaking it out nice and loud. Don't worry, hopefully there's no one else in the room with you. Okay, I'm hoping that you said something like this. An element is a substance made of only one kind of atom. If you said that, well done. So an element is a substance made of only one kind of atom. There are 118 types and they are listed on this organized table. So this is an organized table which lists all the elements. Now, it can look very complicated at first, but we've already learned some things about it. I'm drawing a stepped line now here that goes like this. So it starts along the left-hand side of boron, goes down and under boron, and then it continues in a stepped line like this. And in our previous lesson, we learned what this stepped line separates. So what does the stepped line separate? I want you to speak your answer on 3. 1, 2, 3. You should have said that the stepped line separates the metal elements from non-metal elements. Well done if you got that right. If not, that might have reminded you. What I want you to do now is tell me, what do we find on the left-hand side of this stairs? What do we find on the left-hand side? So 1, 2, 3. You should have said that we find the metal elements on the left-hand side. So over here to the left of the stepped line, these are the metal elements, metals. And on the right-hand side, we find the non-metals. So this means that calcium, which is over here, chromium, silver, aluminium, tin, all of these, because they're to the left of the stairs, are all metals. They're all metal elements. Oxygen, fluorine, helium, sulfur, chlorine, carbon, all of these are to the right of the stepped line. That means that they are non-metal elements. So although this table looks really big and complicated and even a bit scary, it's important to remember that we've already broken it down into one thing that we can, a couple of things that we can say about it. We know what the stepped line is and we know what it shows. And we know that there are some elements that are metals and some that are non-metals. I'm just going to stop talking for a minute. I want you to have a look and browse over the periodic table. Okay. Each element is separated in its own little box. And in its box, you're going to see some numbers, some letters, and a name. Don't worry too much about the numbers for now. We're going to find out what they are later. But I want to introduce you to a problem that we have as a scientific community. We have a problem, and I want to introduce you to what it is. The problem is language. If I was to say compare English language, which is very commonly spoken, with Danish language. Now, it's not as commonly spoken, but it's still an important language in some parts of the world. If we compare the names of some of the elements, take, for example, carbon. Carbon in English is obviously carbon. In Spanish, it's carbón. It's got like I'm not sure what that thing is because I'm not a Spanish speaker, but it's carbón in Spanish. But in English, it's carbon. In Danish, it's kulstof, spelled like this. Obviously, that's quite different. It's very different, in fact. It begins with a completely different letter, and it doesn't actually sound much like it at all. If we take a look at oxygen, oxygen in English is just oxygen. But in Danish, it's ilt, I-L-T. Now that's going to pose some problems. And the problems are that for scientists to be able to communicate with each other, language is a problem. So we need some way in which we can communicate about the elements effectively and people will understand what we're talking about. So we have on the periodic table, we have these letters, and these letters are what we call chemical symbols. So these are symbols. Each element has its own symbol, and it's the same on every periodic table in the world. It doesn't matter what country you are in, they all use the same symbols. Even, for example, the Danish, who call oxygen ilt, it will still have the symbol O like the rest of us have. Okay, it still has the symbol O. So this allows them to communicate with other scientists around the world and speak about the element oxygen by using the symbol O. So that's quite convenient. So we say that chemical symbols represent elements. So chemical symbols represent elements. So each element has a chemical symbol. Another thing to notice, take a quick look, I'm going to say something and you can check, verify that this is correct. The first letter is always a capital. So take a look, some elements have one letter, some have two, but always the first letter is a capital. And it is really important that you write it like this. Many students write things, write things like this. So for example, sodium. Many students would write sodium as Na like this, and they think that that's okay, that that's right. That is wrong because this is not a capital letter. So some elements just have one letter. For example, carbon. Carbon has one letter and it's a C. It's a capital. It's got one letter. Sodium has two letters. The first letter is always a capital and it's N. And the second letter, if there is one, is always lowercase, Na like this. So the rule is like this. First letter is always capital. First letter is always capital. If there is a second letter is always lowercase. Lowercase. Examples of some symbols are like this. We have sodium, which has the symbol capital N, small a. So capital N because it's the first letter, small or lowercase a because it's the second letter. Neon. Capital N because it's the first letter, small e because it's the second letter. So note that these two both begin with N, and this is why they have to have a second letter, because you can't just have two capital N's because people won't know the difference between them. Iron has the symbol capital F, small e, like this. So it's really, really, really important that you write the first letter as a capital and the second letter as a lowercase. It's really important. Okay, for the next bit, we're going to do some questions and practice now. You are going to need a periodic table. So I told you the previous lesson where you can find one of these. You can find one in the back of your textbook. You can find one in your homework journal. Usually there's one there. And in worst case scenario, open up another tab just for this. So open up another tab on your computer to get an online periodic table. So do that now, please. Pause the video and get yourself a periodic table. Okay, welcome back. You should only be watching if you have a periodic table, and we've got some practice questions for you guys to do. Okay, so here they are. Here are the questions. So I want you to pause the video and I want you to do them questions now, please. Okay, so you should only be watching the video if you have paused the video and done the questions. It's really, really important that you do the tasks. Otherwise, you're just not going to learn as much, guys. Okay, you're probably not going to learn anything. So with your correcting pen now, I want you to get a different color pen, red, green, purple, something like that. And you're going to make sure that these are right. Okay, there's no point in just doing the questions, not checking if you have them right. Here are the answers coming up now. So why is it correct? Is this symbol correct? It is not correct, first of all. That's the first one. Well done if you said it's not correct. Then explain why is it not correct? How do you know? Well, it does not begin with a capital letter, so it's got a small b. So that is why it is wrong. So that's what you should have. I correct it if it's right, or fix it if it's wrong. You have to write it correctly now. So you should have written it capital B, small e. That's what you should have. And then you had to use your periodic table to write the symbols for the following equations. Now, you didn't have to put the box like I have. When you're writing the symbol, you don't really have to have it in a box. Just have it written out, the letter out. It's fine. So it's capital C, capital H for hydrogen, capital O for oxygen, capital C, lowercase l for chlorine, and then a capital K for potassium. Well done if you got that right. Make sure you have them corrected. All right, so now you know another little bit about the periodic table. You know two things. You know that, or you know three things, I suppose. You know that it lists all the elements that we know. You know that the stairs divides the metals and the non-metals. You know that the metals are on the left and the non-metals are on the right. And now you know that how to write the symbols. Okay, so you know quite a lot already. We're going to take a little bit of a closer look now. We're going to take a look at one particular element. I'm just going to choose one here. I'm going to draw a box around oxygen. Now, how do I know where oxygen is? Well, I know oxygen has the symbol capital O. It's here. So I'm just going to draw a blue box around oxygen. Now, what I'm going to do is I'm going to bring this down here and I'm going to rewrite it out. So I'm drawing my box for my element down here, and into the box, I'm going to write what I have. I have my symbol for oxygen, which is a capital O. And as well as the symbol, I've got two numbers. I've got a bigger number, which is on top in this periodic table, but it won't always be. Some periodic tables switch the numbers around. So don't learn it as, you know, top and bottom. Learn it as bigger number and smaller number. Okay, so as you see, it's got a smaller number, which is 8, and it's got a bigger number, which is 16. Now, these numbers are not the same for all the elements. Just take a quick look at the elements around oxygen. You will see that those have different numbers. But we'll just focus on oxygen for now, so stay with me. Oxygen's numbers are 8 is the smaller number, and 16 is the larger number. This number here, the smaller number, is something called the atomic number. Atomic number. And it kind of sounds like the word atom, so atom number or atomic number. Okay, it's the smaller number. Okay, now I'm going to do something I don't normally ask you to do. I'm going to ask you to bear with me. I'm not actually going to explain what that number stands for at the moment. We will see it in the next lesson though. So I'm not just leaving you high and dry and saying that's a number. I'm not telling you what it's all about. I just going to wait until the next lesson. Now, I normally don't do things like that. I prefer to tell you as I go, but it just makes sense to do it. It makes more sense to do it in the next one, the atomic number. The other number here is what we call the mass number. The mass number, or what we call, actually not mass number, we sometimes call the mass number, but a better word for it is the atomic mass. Atomic mass. In other words, the mass of the atom. How much mass is in the atom? This is the bigger number. Is the atomic mass. So the bigger number is the atomic mass. The smaller number is the atomic number. I just want to point out something about, no, actually, do you know what? I'm going to do that afterwards. Right, what I want you to do is you're going to take down those notes for me, but you're not going to do it for oxygen. You're going to do it for this element. You're going to do it for carbon. So what I want you to do is make notes of the two numbers of carbon and what do we call each of those numbers. So what I want you to do is pause the video, go to your periodic table, find the numbers for carbon, and then label them as atomic number and mass number, or atomic mass and atomic number. Okay, so atomic mass and atomic number. I want you to do that now, pause the video. Okay, this is what you should have done. Let's go up, check the periodic table. Carbon. Carbon is in the second line here. It's here. There's carbon. It's got the number 6 and it's got the number 12. Capital letter C for the symbol. It's got the number 6 and 12. So 6, I'm going to write it on the bottom, and 12, I'm going to write it on the top. And then you had to label it. So this is going to be part of your notes. And I'm going to label it as, this is the atomic number. And in brackets, what would I say about the atomic number in brackets? So pause the video and write down, what would you say about it? Okay, I'm hoping that you wrote that you would say that it's the smaller number. And I'm hoping that you said that the 12 here is what we call the atomic mass. And it's a bigger number. Now, if you're using a different periodic table, you may notice that this atomic mass is sometimes not a whole number. Now, it's a little bit complicated to explain why that is, but later on in science, you will find out why. For now, just going to assume that we round it to the nearest whole number. Okay, so sometimes you might see carbon's atomic mass as 12.01 if you've got a different type of periodic table. And that's fine. Just know that for now, to keep it simple, we're going to round it to the nearest whole number. Okay, so that's what I want you to do for the moment. So we've got the atomic number and we've got the atomic mass. Okay, so those are the two numbers. What's interesting is if we focus on atomic number for a minute, remember the smaller number. Let's go back to our table, and I'm just going to rub out these blue lines just to make it a bit tidier. I'm going to rub those out, and I'm going to take away that just so that we can focus. I'm actually going to take away the whole lot just so we can focus on what I want to show you. What I want us to do is track the atomic numbers. So the atomic numbers are all written on the bottom here. And what I want you to notice is that hydrogen here is the first element on the periodic table. It's out on its own. There are reasons for that, which we'll get into another time. Helium is the second element, atomic number 2. Then it drops to the next line down, and we've got lithium, beryllium, then boron, carbon, nitrogen. You'll notice that the atomic number is going up. Each time it's going up by 1. So in fact, the atomic number is the way the periodic table is ordered. So the periodic table is ordered so that the elements increase in atomic number. They increase by 1 each time you move from left to right on the periodic table. Okay, so that's a very interesting pattern. A really important thing to know is that the periodic table is arranged by the atomic number. So if I was to ask you, why does oxygen come before neon? So here they are, I'll highlight them. Why does oxygen come before neon in the periodic table? We would talk about the atomic number of oxygen is smaller than the atomic number of neon. So it has to come before the neon in the periodic table. If I was to ask you in a different way, if I was to ask you, why does magnesium come after sodium in the periodic table? Well, we would say its atomic number is bigger than that of sodium. So the periodic table is ordered in order of increasing atomic number. So when atomic number increases, the element goes further down the table. Okay, so that's a really important pattern to notice. Right, it's time to do some more practice now. So what I want you to do is I want you to pause the video, use your periodic table to answer these questions, please. Okay, so you should only be watching the video if you have paused the video and you have answered these questions. I'm hoping that you were able to find these on your periodic table. So what is the atomic number of neon? So you had to get some practice using the symbol to find neon. I'm hoping that you said the atomic number of neon was 10. Now, if you said the atomic number of neon was 20, you would be wrong because that would be the atomic mass. So if I just rub these out here, I'm just going to clean this up. The atomic number is the smaller number. So the atomic number is 10. The atomic mass would be 20. So neon, atomic number is 10. Well done. If you got that right, correct it, please, with a red pen. What is the atomic mass of lithium? The atomic mass of lithium. Well, the atomic mass is the bigger number. So for lithium, this would be 7. Well done, if you got that right. Don't worry, by the way, about having to learn this periodic table off. You never do. I know some of these numbers in my head, but I regularly have to look at the table. I've got one here in the back of my chemistry textbook, and I regularly have to look at it. Sometimes I know the stuff. I know the symbols because I've been using them for so long, and you guys will when you get used to it. But the numbers, don't worry, you do have to look them up, and that's fine. You're better off looking them up than guessing. Find an element with the atomic mass of 19. So this was a little bit more challenging. I give you the atomic mass. You have to find the element with atomic mass of 19. So you should have said atomic mass of 19. The element is fluorine. Well done if you got that right, fluorine. What is the atomic mass of aluminium? That would have been 27. So well done if you said 27. Number 5, find the element with the atomic number of 27. That would be cobalt. Well done if you got that right. And why does potassium come after argon in the periodic table? Potassium comes after argon because it's got a bigger atomic number. It's got a bigger atomic number by 1. So it's 1 bigger in atomic number. So here are the written answers. If you need to, pause the video now, please, and make any corrections that you need to in a red pen. Okay, well done. It's time to move on. I'm hoping that you got those questions right and you found them pretty easy. If not, you need to go back and watch the explanation again. Okay, so in the next little bit, we are going to be taking a look at a little bit more of the different parts of the periodic table. Okay, here is a periodic table, and I am drawing a vertical column. A vertical column. So this is a vertical column. Sorry, I can do a better job than that. This is a vertical column. We call it a vertical column. A vertical column in the periodic table is known as a group. This is a group. So it's called a group in the periodic table. And there are 8 main groups in the periodic table. 8 main groups. Here is group number 1. Here is group number 2. Here is group number 3. Group number 4, 5, 6, 7. And finally, we have a group called group 0. Sometimes this group gets called group 8. That's okay as well, but group 0 is what it's more commonly known as. So again, always remember that a vertical column in the periodic table is a group. Now, all elements within a group have similar properties. Now, what was a property? We learned about properties in the last lesson. So speak your answer to the screen. What is a property? I'm hoping that you said a property is a feature of a material that we can see or we can measure. Now, if we take a look at some example, here, if we take a look at example and we compare lithium, lithium, sodium, and potassium. Lithium, sodium, and potassium. If you look, here they are, lithium, sodium, and potassium, Li, Na, and K. They are in the same group. What do we know about these elements? Well, we know that they are all of them are soft, shiny metals. They are soft. You can actually cut them with a knife, which is very unusual for a metal, but all of these you can. So they are soft, shiny metals that are highly reactive. So they do the same chemical reactions. They all react very violently with things like water. So if we put them into water, they react very violently. When we're back in school, I'd love to show you some of these reactions because they're really cool. Okay, so they are all soft and shiny. These are properties. They are soft and shiny. They are properties. We can see these features, soft, shiny. And they are highly reactive. We can also see this. If we put them all into water, we can see how they react. So these are properties. Now, they're not identical. Because we wouldn't say they have identical properties, we say they have similar properties. If they were identical, then they would all have the they would basically be the exact same element if they were identical properties. They are not identical, they have similar properties. So that's how elements within one group are similar to each other. So when elements belong in a group together in a vertical column, they have similar chemical properties. I am now drawing a horizontal row. There is 1, there is 2, there is 3. Sorry, I shouldn't end number 2 there because it includes also these. So there is 2, there is 3, and so on. It continues down and down. These are what we call horizontal rows. These are horizontal rows. On the periodic table, these are called periods. Period comes from the word, or periods, comes from the word periodic. That's why the periodic table is called the periodic table. Periodic, this just means repeating pattern. Periodic means repeating pattern. If you look at the table, yes, the first group has 2 elements in it, or the first period has 2 elements in it. So this is period number 1, this first green horizontal row. This is period number 2. Now, period number 2 has 1, 2, 3, 4, 5, 6, 7, 8 elements. Period number 3 has 1, 2, 3, 4, 5, 6, 7, 8 elements in it. So as you can see, that's a repeating pattern. So repeating pattern is a period. So a horizontal row on the periodic table, we call these periods. All right, it's time to do some practice now. We are going to take a look at these questions for me now. Okay, so please pause the video and do questions 1 to 6. Okay, so you should only be watching the video if you have answered questions 1 to 6. It's time to go over the answers now. So red pen, we're going to correct these. So what do groups look like on the periodic table? You should have said groups are vertical columns. Okay. What group is calcium in? Calcium is in group 2. So do correct this, please, with your red pen. You should have looked for calcium and found that it was in the second vertical group, number 2. So group 2. Lithium and sodium are both in group 1. Number 4, carbon and silicon are in group 4. And number 5, nitrogen and phosphorus are in group 5. Number 6 was more challenging. Let's take a look at number 6. It says lithium and sodium are in the same group because, and lithium and sodium are in the same group but. So you had to finish writing sentences using those as sentence starters. Now we've seen this type of task before, so it shouldn't be very new to you. Let's see what I have written. So long as your sentence makes sense, it's okay, but you might want to have a read of mine. It says lithium and sodium are in the same group because, well, they have similar chemical properties. So they get put in the same group because they have similar chemical properties. Lithium and sodium are in the same group because they have, but they're in the same group, but they have different atomic and mass numbers. So they're not the identical atoms because they're atomic and mass numbers, atomic masses, sorry. I keep using that phrase instead, and atomic masses. So lithium, sodium, they are in the same group, but they have different atomic masses. Okay, so I want you to pause the video and make any corrections that you have to make there now. Okay. Now, we're just going to very quickly go back and recap it again. That set of questions was about groups. We're just going to really quickly recap this again. A group is a vertical column. There are 8 groups, and all elements within the same group have similar properties. A horizontal row is called a period. So the top line here, up here, this is period number 1. It contains hydrogen and helium. Underneath that is the second period. We call this the second period. The second period contains lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. That is the second period. The third period, the third horizontal row, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. So that is a pattern, what we call the periods of the periodic table. This keeps going, by the way. This is period 4, this is period 5, and this is period 6. All right, you ready to do some more practice? Here we go. Pause the video and do these questions, please. Okay, so you should only be listening to my voice if you have done the questions. It's time to get your red pen, your correcting pen again. Could be green, could be red, could be purple. And here are the answers. Okay, pause the video, make your corrections now. Okay, well done. If you got all those right, that's good going. Really good job today. So let's recap what we now know about the periodic tables. Do one big recap. So this big thing that looked big and scary in the beginning, hopefully isn't so intimidating anymore. What do we know about it? We know it's a list of all the known elements, and we know that the elements are in order of their atomic number. So it starts at atomic number 1, then it goes 2, then it goes 3, 4, 5, 6, 7, and so on. There's no atomic numbers missing. All of them are there. Okay, that's the first thing we know. We know that each element has a symbol. The symbol is the same in every country. Symbols can be 1 letter or 2 letters, but the first letter always has to be a capital and a second letter always has to be lowercase. We know about the steps, the step line. The step line starts at the left-hand side of boron and goes over and down in a step. It separates the metals and the non-metals. Metals are on the left, non-metals are on the right. We know that a group is a vertical column in the periodic table. All elements in the same group have similar chemical properties. And we know that then a horizontal row is a period. Period means, or period comes from the word periodic, which means repeating pattern. Period is a horizontal row, and there are every new line you go to is a new period. So that's the second period, the third and the fourth and the fifth and so on. And you already know a hell of a lot of stuff about the periodic table now. Okay, you already know a hell of a lot of stuff. Now I'm not saying that's everything there is to know. It's a hell of a lot more beautiful and useful than that. There's a lot more patterns that we can find on it, but that's plenty for today. And that's a lot and most of what you're going to need for your junior cert. So well done. I hope you have a better appreciation for the periodic table now, and I will see you in the next video.